So this is the review video for Unit 0 in Math 3. We're going to go through every single question and explain how to do one as we go through. So question 1. All we're doing is combining the like terms. There is no multiplication in this problem. You're just adding up the numbers of the terms that are the same. So we have negative 5x to the third and positive x to the third, which is going to have a 1 in front of it. So negative 5 plus 1 is negative 4x to the third. Remember, we're also putting it in the correct order. We have 7x squared and plus 10x squared, all right, which gives you positive 17x squared, and then negative 8 and negative 2. Negative 8 plus negative 2 is negative 10. Again, remember, we are adding because we're just, see that plus sign in between the two things. And that is our answer. That's it. Do not multiply that because there's a plus sign between the two parentheses. Number 2. Now we have a minus sign between the two parentheses. So again, we are combining like terms, but this time we're subtracting. We have 3x to the fourth and minus 9x to the fourth, which gives us negative 6x to the fourth. Negative 5x to the third. Well, there's no other x to the third in this problem, so that's going to just stay the way it is, minus 5x to the third. Then we have an x, but this x has that minus sign going in front of it, so that's going to give you negative x. And then we have negative 8 minus negative 2. Negative 8 minus negative 2 is negative 8 plus 2, which gives you negative 6. And that is your answer. Number 3. Now in this case, now we are multiplying because there's no add or subtract sign between the two sets of parentheses. We're doing the rainbow method. So 3x times 2x is 6x squared. 3x times 5 is 15x. Negative 7 times 2x is negative 14x. And negative 7 times 5 is negative 35. I have to combine the two terms in the middle that both have an x. So I'm going to have 6x squared plus x minus 35. And then I am done. Number 4. Remember, when this problem like this comes up, this squared means you're going to multiply this term by itself, 4x minus 3. And now we're going to multiply using the rainbow method again. So 4x times 4x is 16x squared. 4x times negative 3 is negative 12x. Negative 3 times 4x is, again, negative 12x. And negative 3 times negative 3 is positive 9. Once more, we have to combine the two terms in the middle that are alike. So we have 16x squared minus 24x plus 9. And number 5, again, we are adding. We are not multiplying here. There is a sign between the two sets of parentheses. So we have negative 5x squared plus negative 4x squared gives you a grand total of negative 9x squared. And then we have positive 3 plus 2 is 5. Now that's all you do. That's the only thing you can do. Number 6. Again, we are subtracting, so you're not multiplying, so please pay attention to those signs between the sets of parentheses. We start off with 4x squared, and minus 6x squared gives you negative 2x squared. Negative 3x, let's do a circle. Negative 3x minus negative 5x is negative 3 plus 5x, which gives you positive 2x. And then the plus 7 is all by itself, so it's just plus 7. All right. This is going to be something that's going to be on the test, something you can, dealing with properties of polynomials or expressions. Okay. So we're going to find an expression that can only be factored by GCF of 3x. So I can take a 3 and an x out of all three terms. Okay. On the first one in number 7, I can't take a 3 or an x out. In number 8, I can take a 3 and an x out. And number 9, I can take a 3 and an x out. And 10, I can take I can't take an x out. Okay, so we're going to say this is going to be this one, A. And the reason being is because later on when I have a GCF of only 6, or just by 6. That wouldn't work for number 9 because I can't take a 6 out of 9. 9 divided by 6 is a decimal. So that means that goes for this one. I can take a 6 out of that. I can also take an x, but we can just take a 6 out. Okay? Actually, I lied. Hold on a second. I know where they're going with this. We're going to say b is down here. You can take a 6 out of that. The other one you can take a 6 and an x out. So that's going to be the d. And then the expression cannot be factored is c. There's nothing you can take out of c because 11 and 2 don't share a common number and x squared doesn't have a number. And there's no x on the 2, so that means you can't take anything out of that problem. Okay? The reason number 10 is b is because you can take a 6 out, but that's it. Nothing else can be taken out of that question. All right? All right, so that's the way it should work. All right, next, number 11. Factor each expression completely. All right, oops, there we go. So this is a simple factoring. This is not a solving. You're just going to factor it because it's an expression. There is no equation. Okay, so we have x and x. Drop the first sign. What times a positive gives you a positive? That would be a positive. What are the factors of 5? Well, there's only 2, 5 and 1. Okay, so put the biggest number first. 5 times 1 is 5, and 5 plus 1 is 6. So that is it. You're done. Number 12. You can't take a GCF out of this, but this is a difference of 2 squares problem. Both numbers are perfect squares. So you're going to have x and x, plus and minus, and the square root of 64 is 8. And that is it. Okay, we know it's a difference of 2 squares because it's only 2 terms, and they are both perfect squares. Number 13. Now in this problem, I'm looking for the greatest common factor. I can take a 2 out of everything. I can also take x squared out of everything. Each term has at least 2 x's in it. Okay, when I figure out what's left, I'm going to divide each term by 2x squared. So I will get x squared plus 4x minus 21. Okay, what's left over inside the parentheses is also factorable. So I'm going to factor that as well using simple factoring. I'm going to bring down my 2x squared because it's still part of the problem. All right, so I drop the first sign, which is a plus. What times a positive gives you a negative? That would be a negative. Factors of 21, I know we're going to be 7 times 3. And when you add those together, because the signs are different in my parentheses, I got a plus and a minus, I'm going to subtract the factors. And 7 minus 3 is 4. So the biggest number goes first, and I am done. Number 14. The greatest common factor of this, you can take out something. I can take out a 7, and they both have an x. I'll be left with x squared minus 4. Now I can see that inside my parentheses, I have a difference of 2 squares, just like problem 12. I have two terms in my parentheses. They're both perfect squares. I'm going to rewrite the 7x because it's still part of my problem. All right, my 2 sets of parentheses. I have x and x, plus and minus, and the square root of 4 is 2. So I'm going to put both 2's. And that is done. Number 15. Now, I don't see any greatest common factor I can take out. 2, 7, and 3 don't share a common term, and there's no x on the 3, so I can't take an x out either. So this becomes an advanced factoring question. All right, so I'm going to multiply 2 times 3, which gives me 6. I've got to find the factors of 6 that make up 7 when added together. So 6 times 1 is 6, but 6 plus 1 is 7. I'm going to use the bottoms up method, so I'm going to put the denominator of the a term, which is right here, of 2 in the denominator, and then reduce my fractions. So I'm going to get 3 over 1, 1/2. X's go on the bottom, they come up to the top. So we get x plus 3 and 2x plus 1. And I've just factored number 15. Number 16. Again, looking for greatest common factors. 3, 10, and 8 don't share a common term, and there's not enough x's in all the terms to take out. So again, I'm going to do advanced factoring. 3 times 8 is 24. The factors of 24 that add up to be 10 would be 6 times 4. and I'm going to do bottoms up. So I'm going to take that a value of 3 and make it my denominator in my fractions. So 6 over 3 is 2 over 1, and then 4 over 3rd cannot be reduced. Put an x on the bottom, bring it up to the top. So I have x plus 2, I have 3x plus 4. That is my factorization. Okay, now when we get to solving later on, we're going to do the same kind of stuff for most of the problems. It's just then we're going to take our factors individually and set them equal to 0 and solve, which is what we're going to do next. Now number 17 was a really big problem on the formative. This is mostly done for you. It's already been factored. So all you do is take the factored pieces, set them both equal to 0, and solve for x. I'm going to add 2 and divide by 5. And I'm going to subtract 3. And that is all I had to do to solve my factors. Okay, I didn't have to multiply it out and put it in the quadratic formula. There's no need to. Quadratic formula would be unnecessary to do in question 17. Number 18. Before I can start solving this, I have to make it so that it equals 0. So I'm going to put x squared minus 9x. I'm going to add the 8 to the left, so it's going to be plus 8 equals 0. Now this, I'm pretty sure I can factor using simple factoring. I have an x and an x. I'm going to drop the first sign, which is a minus. What times a negative gives me a positive? That'd be another negative. Factors of 8 would be 2 times 4 and 1 times 8. Since the two signs in my parentheses are the same, I'm going to add, and 1 plus 8 gives me 9. So the numbers go largest to smallest. And now I factor the problem. Now I take my factors, set them both equal to 0, and solve. So x will equal positive 8, x will equal positive 1. That's it. I factored it, take my factors, set them equal to 0, and solve. Could I have put it in the quadratic formula? Yes, after I put it into this format, but it's easier to factor it than to put it in the quadratic formula for this particular problem. All right, this one's a little bit harder, number 19. So we're going to actually multiply this out. Okay, so we're going to have x minus 5 times x minus 5. And then I'm going to put a minus 1 on the end for later. If I multiply this out, I'm going to have x squared minus 5x on the other side, minus 5x again, plus 25. Okay, and I have that minus 1 at the very end. So now I'm going to combine my like terms here of x squared minus 10x plus 24. And now I set it equal to 0. All right, so now I can factor this. It's a simple factoring, x and x. Drop the first sign, which is a minus. What times a negative gives you a positive? That's again another negative. Factors of 24, I have to equal 10. I'm going to use 6 and 4. Because the two signs are negative, they're the same, I'm going to add my factors. And 6 and 4 add up to give you 10. So 6 goes there, 4 goes there. And now again, because I factored it, x minus 6 equals to 0, x minus 4 equals 0. Solve both for x. So x will equal positive 6, and x will equal positive 4. That's it. Number 20. Now this, again, is not in the right format. It has to equal 0. So I'm going to actually bring this stuff from this side over to the other side. All right. I'm going to do that. I'm going to do that by subtracting 8x to the left and adding 3x squared to the right, or sorry, to the left as well. Okay, so I will have 3x squared minus 8x plus 4. Now the reason I did that is because I don't want this term to have a negative sign. That negative sign in front of the 3 is why I moved everything to the left. Okay, now it's positive, and now it's easier to solve. Set it equal to 0. Now, I can try factoring this. Let's try it and see what we come up with. So 3 times 4 is 12. 2 factors of 12 that multiply to give you -8. Oh, okay. 6 and 2. But it's going to both be negative. So -6 times -2 is +12. And -6 minus 2 is -8. So I can factor this. Just like before when I did it, bottoms up method up top before when we did the expressions. I'm going to make my denominator the a value. Here's the a value. Okay, so -6 over 3 gives you -2 over 1, and -2/3 cannot be reduced. I have an x in the bottom. Bring it to the top. So I have x minus 2 and 3x minus 2. Okay. Now, again, now that I've factored, I can put these factors, set them equal to 0, and solve for x. So I'm going to add 2 for the first one. The second one, I'm going to add 2 and divide it by 3. And then I'm done. Now, could I have used the quadratic formula for that? Yes, but then I would have had to keep going because it was factorable. Now in 21, this can't be factored. I know this because the 2 factors of 1 are 1 and 1, and 1 and 1 will not give you 8 anyway. So this I have to put in the quadratic formula. I do not have a choice. So the a value goes there, b is there, c is there. I'll write it out. So this is a, b, and c. Okay, now the quadratic formula was given to you, where is it? All the way up there in the top corner. It will be given to you on the test as well. So, in the formula it's -b. Since the b is already negative, it's going to be +8 plus or minus the square root of b, -8 squared. Notice I put that -8 in parentheses. Minus 4 times 1 for the a times the c is -1. All over 2 times the 1 value. Or sorry, 2 times 1, which is the a value. So that's what your formula should look like. Notice the plus or minus between the 8 on the front and the square root sign. All right, now we have to just do this. So the 8's going to stay the way it is. -8 squared is 64. Okay. And then minus 4 times 1 times -1. So this part here will add up or multiply to be +4. Since the -8 squared is +64, plus 4 gives you +68. Let's erase my tail there. All right, now another thing that some students missed, that line has to go all the way across. And then 2 times 1 is 2. Now, you cannot we're not reducing the square to 68 because it's not a perfect square. So this is as far as you can go. That would be your answer. So just figure out what's underneath the square root sign as a number, and then if it's not factorable, you're going to leave it like this. 22. Now in 22, this is a difference of 2 squares problem. We've done these before when we just did expressions. So I have x and x plus and a minus. The square root of 100 is 10. I just take each of these factors, set them equal to 0. So x will equal -10, and x will equal +10. All right, next problem, 23. All right, you've done a problem like this before. We're going to square what's inside, so we're going to have x plus 2 times x plus 2. I'm going to put plus 5, and I'm going to subtract the 14 over to the other side so I can have this equation equal to 0. Okay, so if I multiply the x plus 2's, x times x is x squared, x times 2 is 2x, 2 times x is 2x again, 2 times 2 is 4. Oops, get the plus. And then plus 5, and then minus 14. All right, I'm going to combine my like terms. The x squared has nothing to combine with. The 2x's or there's two of them, so it's going to be 4x. And then 4 plus 5 minus 14 is going to be, let's see, negative 5. And that's going to equal 0. All right, I should be able to factor this. Drop the first sign, which is a plus. What times a positive gives you a negative? That would be a negative. Factors of 5 are 5 and 1. And since the signs are different in the parentheses, I'm going to subtract those, which gives me 4. 5 and 1. So 5 minus 1 is 4. 5 times negative 1 is negative 5. So I've now factored this. I again take my two factors, set them equal to 0, and solve for x. So I'm going to subtract 5, gives me negative 5. And I'm going to add 1, which gives me positive 1. Number 24. I have to set this equal to 0. So I'm going to have x squared plus 3x. I'm going to subtract the 10 to bring it to the other side, and it equals 0 now. Okay. I'm going to see if I can factor this. X and x. Drop the first sign, which is a plus. What times a positive gives you a negative? That would be a negative. The factors of 10 are 1 and 10, and 2 and 5. Well, 2 and 5, because the two signs are different in my parentheses, I'm going to subtract, and 5 minus 2 gives me 3. So I'm going to have 5, the bigger number first, and then 2. Set my factors equal to 0, and then solve for x. So I'm going to subtract 5, so it's negative 5, and I'm going to add 2, so it's positive 2. Okay, notice, out of all these problems, I did quadratic formula once, just once. Most of the problems are factorable, okay, and we're a lot better at factoring than we were at quadratic formula. So just please remember that when you're taking the test. All right, evaluating expressions. I have two functions. I have the g function here, and I have the h function here. So we're going to use these functions with our problem. So I'm putting negative 8 into the g function. I'm going to rewrite the g function just the way it looks. I'm going to put minus, I'm going to put parentheses with 5, plus. Now I'm going to replace the x in my g function with negative 8. I'm going to put it in parentheses. Then there's another parentheses with a squared on it. Now this is an issue on the formative. You have to combine the stuff inside the parentheses first. That's the first thing you do. So we're going to get negative 5 plus negative 8 is negative 3. Then I have that squared. The next thing you do for this problem, before multiplication becomes exponents, you're going to square the negative 3, which negative 3 squared is going to be, negative 3 squared is going to be positive 9. And now that negative gets multiplied by the 9, your answer is negative 9. Number 26, we're going to put 3 in for the x's of the h function. So I'm going to put 2, I'm going to put 3 for the x there, and square it, minus 4, and then 3 again for the x. All right. With this problem, again, the squared sign goes first, not the multiplying by 2. 3 squared is 9 times 2. On the other side, 4 times 3 is going to be 12. There's nothing else to do besides that. And to finish this problem off, 2 times 9 is 18, and 18 minus 12 is 6. Okay, 27. Again, we're using the h function, putting negative 4 in for the x's. So we have 2 times negative 4 squared minus 4 times negative 4. Notice I'm putting the negative 4 in parentheses every time I replace an x. Okay, everything else is the same. I'm just replacing the x term with a negative 4. So again, the squared sign goes first. So I have 2, negative 4 squared is positive 16. Negative 4 times negative 4, again, is positive 16. So 2 times 16 is 32. 32 plus 16 is 48. All right, and lastly, we have g of 0. I'm going to put the g function, so it's minus, with the parentheses 5, plus I'm going to put 0 in parentheses, with the parentheses squared. That's what it should look like. Again, the stuff inside the parentheses has to be done first. So 5 plus 0 is, no, I did it again. 5 plus 0 is 5. squared. Next, we do the squared. 5 squared is 25, which gives me negative 25. Okay? Lastly, looks like we're doing the technology questions. That's it. We're almost done. 4 more questions. So I'm going to get in the Desmos app here. Actually, hold on. Let's go back to that. Oh, sorry. My apologies. Had some technical problems. All right. There we go. There we go. All right. So let's look at this. I'm going to find the point of intersection between the 2 points, or between the 2 lines, sorry. I'm going to write out my equations just the same way they have it on the sheet here. 5x plus 2, and then 2x plus 16. So that's what I have. So let's go the graph first. Again, you have to make the graph that you have very similar to the one that's on the graph that you have. So we have this for the blue one. Let's make that a little better. You have this for the blue one, and we'll even change colors so it looks exactly the same. And you have this for the red one. Okay, and they're gonna cross right here. All right, so we have our sketch. Now we got to figure out where the intersection is. So you click on the point where they intersect, and it's negative 2, 12. Okay, that's the first one. The next one. Let's delete all this stuff. Actually, let's just do that. It's quicker. All right, so we have 2x plus 6 for the first one, and then we have 3x plus 1 for the second. All right, we got that right? Yep. So we're going to look at these 2 things when we're graphing. So we'll do a blue line, which goes here, and another line that goes here. Okay, that's about good enough. All right, we want to find out where they intersect. Oops. And it is 5, 16. So very simple. So make sure your lines kind of match with the ones that we're doing in Desmos. Okay. Next, we're going to find the y-intercept. So we have one big equation, so you're going to make sure that you type it out just the way it shows you on the problem. So we have 2 minus, then we have parentheses, x plus 4, then we have squared plus 5x squared plus 8. Okay, so it's going to be a parabola. It's going to go like this. Okay. I'm going to find the y-intercept, which is where it crosses the y-axis. So touch the graph, touch the point where it crosses the y-axis. We have 0, negative 6. One more. We have 3x minus x minus 1, parentheses, squared, plus 8x squared plus 5. So we have just the way we've written it down there on the piece of paper, or on the review sheet. Okay, we're going to zoom in a little bit so we can graph it. It looks like this. It does not go through the x-axis. It goes like this. Okay, finding out what point that is 0, 4. That is the y-intercept. And that, ladies and gentlemen, is the entire review sheet, all done for you as a video. All right, good luck on the test. If you have questions, please make sure you ask before you take the test.